Have you ever pressed your ear against the hollow body of a guitar and felt the wood hum with invisible energy, a resonance that lingers long after the last note fades? Now stretch that sensation across the infinite expanse of the cosmos. Out there, in the silence between stars, the universe itself thrums with a hidden vibration, a ghostly echo woven into the fabric of space and time. This isn't science fiction. It's the startling reality that physicists and philosophers have chased for centuries, the phantom vibration of the universe, a symphony of resonant frequencies that might just hold the key to understanding everything. Think of the last time you stood beneath a starry sky, struck by the sheer scale of it all. What if I told you that emptiness isn't empty at all? That the void between galaxies pulses with energy, like the quiet hum of a tuning fork struck at the dawn of creation. From the ancient Greeks who envisioned the music of the spheres to modern astrophysicists mapping cosmic microwave background radiation, humanity has been obsessed with one haunting question: why does the universe vibrate? And what happens when we listen? This is the story of harmonic cosmology, a journey where science and wonder collide. We'll trace how Einstein's equations hinted at ripples in space-time long before we could detect them, how black holes ring like bells in frequencies we're only beginning to measure, and why some researchers believe these cosmic vibrations could reveal hidden dimensions or even parallel universes. But more than that, it's a story about connection, because if the cosmos truly sings, then every atom in your body is part of that chorus. So let's unravel this mystery together, from the first faint whispers of the Big Bang to the harmonies that might one day explain the deepest secrets of existence. The universe isn't just speaking, it's composing a masterpiece, and you're about to hear it. Every atom, every star, every swirling galaxy dances to an unseen rhythm, a vibration so fundamental it stitches reality together. Picture a spiderweb glistening with morning dew, trembling at the slightest touch. Now imagine the entire universe as that web, resonating with countless vibrations, each telling a story. When scientists first detected gravitational waves in 2015, ripples in space-time from colliding black holes, they weren't just observing an event. They were hearing the universe's heartbeat, a low-frequency thrum that had traveled over 1 billion years to reach us. But this symphony isn't new. Pythagoras, the ancient Greek philosopher, believed celestial bodies moved in perfect harmonic ratios, creating a music of the spheres too sublime for human ears. Hindu texts described cosmic sound as the primordial vibration from which all creation emerged. These weren't just poetic metaphors. Modern astrophysics reveals that planets orbit in resonant patterns, like Jupiter's moons locking into gravitational harmonies, or pulsars emitting radio waves with the precision of a metronome. Even the afterglow of the Big Bang, the cosmic microwave background, carries faint imprints of those first vibrations, like echoes of a drumbeat from the dawn of time. What's truly mind-bending is how these frequencies might unlock cosmic mysteries. Take dark matter, the invisible glue holding galaxies together. Some theories suggest it could be made of ultra-light particles vibrating at frequencies we've yet to detect. Or consider quantum fields, where particles are merely notes in an endless vibrational spectrum. Even the fabric of space-time itself may be woven from microscopic strings vibrating in higher dimensions, as string theory proposes. The deeper we listen, the more the universe reveals itself not as a static void, but as a dynamic, singing entity, one where every vibration, from the hum of a quark to the roar of a supernova, is part of an eternal chorus. So next time you feel your phone buzz in your pocket, remember, it's not just a notification. It's a fleeting echo of the same universal vibration that's been pulsing since the first moment of existence. And somewhere out there, the cosmos is still singing. That phantom buzz in your pocket, the one that tricks your brain into thinking your phone just lit up, isn't just a quirk of modern life. It's a tiny echo of something far grander, a cosmic version of the same phenomenon playing out on a scale so vast it defies comprehension. Out in the depths of space, astronomers have stumbled upon a vibration without a source, a hum so pervasive it blankets the entire universe. Imagine standing in a dark room, hearing a faint, persistent drone, but no matter how hard you search, you can't find the speaker. That's precisely the puzzle scientists are facing right now. This cosmic hum isn't some abstract idea. It's been measured. Gravitational wave detectors, like the Laser Interferometer Gravitational Wave Observatory, or LIGO, have picked up a background murmur of low-frequency ripples in space-time. It's as if the universe is a giant drum and something, or many somethings, are keeping it gently throbbing. But what's causing it? One leading theory points to the collisions of supermassive black holes, events so violent they send shockwaves through the fabric of reality itself. These mergers could be happening constantly, far back in cosmic history, their combined vibrations reaching us as a faint, eternal whisper. Then there's the wilder possibility, primordial gravitational waves, ripples left over from the Big Bang. Think of the universe's birth as a bell struck with unimaginable force. Even after billions of years, the ringing hasn't completely faded. If that's true, this hum isn't just noise, it's a direct line to the first moments of existence, a fossilized echo of creation itself. But not all explanations are so poetic. Some researchers speculate it could be the collective wobble of neutron stars, or even the vibration of cosmic strings, hypothetical flaws in space-time left over from the universe's fiery infancy. The most tantalizing part, this hum might be hiding clues to physics we don't yet understand. Could it be evidence of extra dimensions vibrating just beyond our perception? Or the signature of dark matter interacting in ways we've never detected? Every new observation deepens the mystery, blurring the line between astrophysics and philosophy. Because if the universe really is humming, it's not just a scientific curiosity, it's a reminder that reality is far more dynamic, far more musical than we ever imagined. And the next time your phone buzzes with nothing there, remember, you're not just imagining things, you're tuning in, however faintly, to the same cosmic vibration that's been playing since the beginning of time. Pythagoras wasn't just a mathematician, he was a mystic who heard music in the movements of the stars. Centuries before telescopes or particle accelerators, he claimed the cosmos operated on harmonic principles, with planets orbiting in ratios as precise as the intervals of a lyre's strings. Today, that audacious idea doesn't seem so far-fetched. Modern physics reveals a universe where vibration isn't just a metaphor, it's the bedrock of reality. Take string theory, which suggests every particle is a microscopic string vibrating at unique frequencies, like notes on some cosmic instrument, the electron. A high-pitched hum, the quark, a deeper, resonant thrum. Even the forces of nature could be harmonies in this grand symphony, with gravity as the bassline and electromagnetism as the melody. But here's where it gets truly fascinating. Ancient spiritual traditions, from Hindu mantras to Tibetan singing bowls, have long claimed that sound shapes reality. The Vedas describe creation arising from the vibration of Nada Brahma, the sound of the divine. Indigenous cultures used drumming and chanting to alter consciousness, as if tuning into a hidden frequency. Now, cutting-edge research hints they might have been onto something. Studies show certain sound frequencies can influence brain waves, even induce meditative states. Could consciousness itself be a form of resonance, a dance of vibrations in the neural networks of our brains? Some scientists speculate that the universe's hum might not just be physical. It could be experiential, weaving matter and mind into a single, vibrating tapestry. This convergence of science and spirituality challenges our deepest assumptions. If the universe is musical, does that mean it's also mindful? Philosophers like Leibniz imagined reality as a pre-established harmony, while quantum physicists now speak of entanglement particles harmonizing instantly across vast distances, as if sharing an invisible score. Perhaps the most radical idea is that we're not just observers of this cosmic song, but participants. Every thought, every observation might subtly tweak the universal vibration, like a pianist adding a note to an endless composition. So where does this leave us? Staring into the night sky, we're left with a thrilling possibility. The universe isn't just humming, it's improvising, and in ways we're only beginning to grasp, we might be singing along. Resonance is the universe's hidden grammar, a silent syntax that sculpts everything from the spin of electrons to the spiral arms of galaxies. Picture a child on a swing. Push at just the right moment, and each nudge amplifies the motion. Now scale that up to cosmic proportions. When frequencies align across the vastness of space, they don't just create harmony, they build reality itself. Take our own solar system. The orbits of planets aren't random. They're locked in resonant patterns, like Jupiter's moons Europa and Ganymede, whose gravitational dance ensures they always meet at the same points in space. This isn't coincidence, it's physics writing poetry. But resonance goes far beyond celestial mechanics. Here on Earth, the Schumann resonance's electromagnetic waves bouncing between the planet's surface and the ionosphere pulse at frequencies eerily close to human brainwaves. Some researchers speculate this isn't an accident. Could life itself have evolved to sync with these planetary vibrations? It's a provocative idea, especially when you consider how many cultures describe altered states of consciousness using rhythmic drumming or chanting, as if tuning into some primordial frequency. Now stretch this concept to the fabric of space-time. Physicists study what they call Eigen frequencies, the natural vibrational modes of the universe. Imagine space-time as a vast drumhead with every massive object, stars, black holes, even the remnants of the Big Bang, plucking its surface, sending ripples outward. These aren't just mathematical abstractions. In 2017, LIGO detected gravitational waves from colliding neutron stars, and the resulting ring-down matched predictions of spacetime's Eigen frequencies with stunning precision. It was as if the universe had sung a note, and we'd finally learned to listen. What's truly mind-bending is how these resonances might explain one of cosmology's greatest mysteries, the fine-tuning problem. Why do the fundamental constants of nature, the strength of gravity, the mass of an electron, seem perfectly calibrated to allow life to exist? One compelling theory suggests these values aren't arbitrary. They could be the inevitable result of resonant interactions in higher dimensions or echoes from an earlier cosmic cycle. Even the distribution of galaxies isn't random. They cluster in patterns that resemble standing waves in a vibrating medium. So the next time you hear two musical notes harmonize, remember, you're witnessing the same principle that shaped the cosmos. From quantum fields to galactic superclusters, resonance is the unseen architect, the silent composer of all we know. And as we learn to decipher its language, we might just uncover the universe's deepest secrets written not in equations, but in vibrations. The moment the universe burst into existence wasn't some quiet flicker. It was a cataclysmic overture, a deafening chord struck across the void. And just like the lingering echo in a cathedral long after the choir has gone silent, that primordial vibration never truly faded. We can still hear it today, not with our ears, but through the cosmic microwave background, a faint glow permeating every corner of space, the afterimage of creation's first light. Picture an old vinyl record left out in the sun, warped by time but still faintly playing the song pressed into it 14 billion years ago. That's the CMB, the universe's oldest recording. But here's what's astonishing: those subtle variations in the CMB's temperature, mapped in exquisite detail by satellites like Planck, aren't random static. They're the fossilized imprints of sound waves that rippled through the newborn cosmos. Imagine the early universe as a seething ocean of plasma, dense and turbulent. Gravity would pull matter together, while radiation pressure pushed it apart, creating rhythmic pulses, cosmic tsunamis racing outward at half the speed of light. As the universe expanded and cooled, these waves froze in place, leaving behind a fingerprint in the CMB's delicate temperature fluctuations. Like grooves on a record, these patterns encode the universe's opening notes. What's truly revolutionary is how these ancient vibrations became the scaffolding for everything we see today, the slightly denser regions where those sound waves peaked. Those became the seeds for galaxies, the quieter troughs, the vast cosmic voids between them. It's as if the universe composed its own blueprint through resonance, with the CMB as its musical score. Scientists can even replay these primordial sounds by converting the CMB's temperature variations into audio frequencies. The result, a deep, resonant hum, the lowest note imaginable, 57 octaves below middle C. Yet the CMB holds deeper mysteries. Some of its patterns don't quite match our predictions, hinting at physics beyond the standard model. Could these anomalies point to extra dimensions, or evidence of a universe that existed before the Big Bang? Then there's that axis of evil, an eerie alignment of large-scale fluctuations that some theorists suggest might indicate our universe has a preferred direction, like a guitar string vibrating along a specific plane. We're not just decoding the past when we study these echoes. We're glimpsing the universe's fundamental nature, one where vibration isn't incidental but foundational. From the quantum buzz of particles to the gravitational waves from colliding black holes, everything sings. And the CMB, it's the first verse of an epic still being written, a reminder that the universe doesn't just exist, it resonates. Black holes don't just swallow light, they sing. When two of these cosmic giants spiral toward each other in a death dance, they don't collide silently. The impact sends shockwaves through the very fabric of space-time, vibrations so powerful they ripple across billions of light years. These gravitational waves aren't mere disturbances, they're musical notes ringing out in the darkness, carrying secrets about the black holes that created them. Think of a bell struck underwater, sending out pulses you can feel more than hear. That's how LIGO first detected gravitational waves in 2015, not with telescopes, but with lasers measuring distortions smaller than an atom. The signal matched predictions perfectly, a rising chirp as the black holes circled faster, then a sudden dong when they merged. But here's what's astonishing: that final ring down wasn't chaos. It was a clean, decaying tone, revealing the new black hole's mass and spin with precision. Scientists call these quasi-normal modes, the characteristic frequencies at which a black hole vibrates after a collision. It's as if each black hole has its own voice print, a cosmic fingerprint written in vibrations. Now imagine thousands of these mergers happening across the universe, their gravitational waves overlapping into a constant low-frequency murmur. That could explain part of the mysterious cosmic hum, an ocean of bass notes from black holes that merged eons ago, their combined echoes still washing over us. Some theories suggest supermassive black holes, billions of times heavier than our sun, might be humming even when they're not colliding. as stars and gas clouds fall toward them, they could generate steady gravitational vibrations like a bow drawn endlessly across a cosmic cello string. But black holes might be hiding even stranger harmonies. Some physicists speculate that their event horizons, the points of no return, could vibrate in ways that reveal quantum structures beneath. It's like tapping a wine glass to guess how much liquid it holds, except here the glass is a warp in space-time, and the liquid might be strands of fundamental strings. Then there's the holographic principle, which suggests all the information inside a black hole gets encoded on its surface, vibrating in patterns we're only beginning to decipher. What emerges is a stunning realization. Black holes aren't just destroyers, they're composers in the universal orchestra, their deepest notes resonating long after the visible fireworks fade. And with every new detection, we're not just observing the cosmos, we're learning to hear it. Down in the quantum realm, where particles flicker in and out of existence like fireflies in a midnight field, the universe reveals its most intimate symphony. This isn't the grand, sweeping music of colliding black holes or the deep hum of cosmic background radiation. It's something far stranger. Here, at scales so small they defy imagination, empty space itself thrums with energy. Quantum fields vibrate ceaselessly, and what we call particles are merely temporary crests in this endless sea of motion, like fleeting notes in an eternal composition. Take zero-point energy, the lowest possible vibration a quantum system can have. Even at absolute zero, when all classical motion should cease, the quantum world never rests. It's as if the universe is incapable of silence, always humming with residual energy. This isn't just theoretical. The Casimir effect proves it. Place two uncharged metal plates impossibly close together in a vacuum, and they'll be pushed together by the sheer pressure of quantum fluctuations outside them. It's like trying to clap in a room where the air itself is alive with whispers. You can't escape the vibration. Now, stretch this idea to the cosmos. Some physicists believe these quantum vibrations might hold the key to one of the biggest mysteries in science: dark energy. That unexplained force accelerating the universe's expansion could be rooted in the zero-point energy of space itself. Imagine blowing up a balloon with tiny, invisible springs woven into its rubber. The more it expands, the more those springs push outward. If the fabric of space-time behaves similarly, then the universe isn't just growing, it's being propelled by the endless buzz of its own quantum foundation. But the real marvel is how these microscopic vibrations might scale up to shape reality. String theory suggests that every particle is a minuscule string vibrating at a unique frequency, with different notes corresponding to electrons, quarks, or photons. In this view, the universe isn't built of static objects but of dynamic harmonies, a cosmic orchestra where the laws of physics are simply the rules of resonance. Even the randomness of quantum mechanics could be understood as overlapping vibrations, like the chaotic yet patterned noise of a rainforest at night, where countless creatures contribute to the whole. What if we could listen? Converting quantum fluctuations into audible sound reveals a cacophony of pops and hisses, a reminder that what we perceive as stillness is anything but. Some researchers speculate that consciousness itself might arise from vibrational patterns in the brain's microtubules, as if our thoughts are melodies played on quantum strings. It's a dizzying thought that the universe's deepest song might not just surround us but be us. So when you next feel the solidity of a table or the warmth of sunlight, remember, you're not touching objects but vibrations. The universe isn't just singing, it's improvising at every scale, from the quantum hum of an atom to the resonant echoes of colliding galaxies. And in that realization, we find a truth both ancient and cutting edge. reality isn't a thing but a performance. One we're all part of, whether we hear the music or not. Imagine plucking a guitar string and watching the vibration blur into a shimmering ribbon. Now shrink that image down 1 trillion times until the string itself becomes the smallest building block of reality. That's the breathtaking premise of string theory, the idea that every particle in existence, from the photons carrying light to the quarks inside atoms, isn't a point but a tiny, oscillating filament of energy. Each vibration pattern, like different finger placements on a violin string, produces a distinct note that manifests as a unique particle, the electron. A tight, high-frequency hum, the graviton, the hypothetical carrier of gravity, a deeper, resonant thrum. In this view, the universe isn't just filled with music. It is music, an intricate composition played on countless vibrating strings. But string theory isn't just poetic. It's a potential key to one of physics' greatest puzzles, uniting Einstein's theory of gravity with the chaotic rules of quantum mechanics. For decades, these two frameworks have clashed like dissonant chords. General relativity paints gravity as the curvature of space-time, while quantum mechanics describes particles as probabilistic waves. String theory elegantly bridges the gap by suggesting that gravity emerges naturally from the same vibrational fabric as everything else. Picture an orchestra where the violin section represents electromagnetism, the brass embodies the strong nuclear force, and the double basses, those deep, resonant vibrations, are gravity. Suddenly, the cacophony resolves into harmony, yet there's a catch. For the math to work, string theory demands extra dimensions, not just the 4 we experience, 3 of space, 1 of time, but 6 or 7 more, curled up so tightly they're invisible to us. Think of a garden hose seen from a distance. It appears one-dimensional until you zoom in and realize it's a cylinder. Similarly, these hidden dimensions might be compactified, shaping the vibrational patterns of strings in ways we're only beginning to model. Some theories propose these dimensions aren't random but form intricate geometric shapes called Calabi-Yau manifolds, structures so complex they resemble frozen musical harmonies in higher dimensional space. The most tantalizing implication: if string theory is correct, the universe operates not through rigid laws but through vibrational relationships. The mass of an electron, the speed of light, these wouldn't be arbitrary constants but natural outcomes of how strings resonate across dimensions. Even the vacuum of space would hum with latent energy, as string vibrations constantly birth and annihilate particles in a quantum froth. It's a vision that blurs the line between physics and art, where equations become melodies and the cosmos is less a machine than a living, breathing composition. Of course, skepticism remains. Without direct experimental proof, no microscope can yet see these strings. Some dismiss it as mathematical fiction. Others counter that the theory's very elegance hints at truth, much as Pythagoras' harmonic ratios predicted planetary motion millennia before telescopes. And while we may never hear these strings directly, their vibrations might leave faint echoes in gravitational waves or quantum entanglement experiments. What's undeniable is how string theory reframes our place in the universe. If all matter is vibration, then the screen you're watching, the air you're breathing, even the neurons firing in your brain are part of an eternal symphony. The ancient concept of as above, so below takes on new meaning. The same principles governing galaxies might pulse through every atom, every thought. So the next time you hear a song, remember, you're not just listening to music, you're glimpsing the deepest language of reality. In 1787, a German physicist named Ernst Chladni did something deceptively simple. He scattered fine sand across a metal plate and dragged a violin bow along its edge. What happened next would captivate scientists and artists for centuries. As the plate vibrated, the grains of sand skittered away from areas of maximum motion, gathering along the stationary lines where the vibrations cancelled out. Within moments, intricate geometric patterns emerged: stars, spirals, and mandala-like designs that looked less like physics and more like sacred art. These Chladni figures weren't just beautiful accidents. They revealed a profound truth. Vibration has a hidden grammar, one that organizes chaos into breathtaking symmetry. Now zoom out, way out. Picture the observable universe mapped by modern telescopes, with galaxies clustered in vast filamentary webs stretching across billions of light years. At first glance, these cosmic structures appear random, but statistical analysis reveals something startling. Their distribution mirrors Chladni's sand patterns almost uncannily. Both are shaped by resonance, standing waves that sort randomness into order. In Chladni's experiment, it was the plate's natural frequencies arranging the sand. In the cosmos, it was sound waves rippling through the primordial plasma after the Big Bang, leaving denser regions where galaxies would eventually form. The universe, it seems, is a Chladni plate on a scale so vast it defies comprehension. This isn't just poetic coincidence. Mathematically, both systems follow the same principles of wave interference and harmonic nodes. When astronomers simulate the universe's evolution, they input equations for acoustic oscillations, literal sound waves, into their models. The results: virtual universes that grow to resemble our own, with galaxies clustering along resonant lines like sand on a vibrating plate. Even the spacing between these cosmic filaments matches predictions based on harmonics, as if the early universe were a tuning fork struck with unimaginable force. What's truly mesmerizing is how this resonance bridges disciplines. Architects use Chladni-like principles to design earthquake-resistant skyscrapers that dissipate vibrational energy. Biologists find similar patterns in the arrangement of leaves on a stem or the segmentation of embryos, all governed by oscillating chemical signals. From the microscopic to the galactic, nature seems obsessed with organizing itself through vibration. So the next time you see a snowflake symmetry or the fractal branching of a river delta, remember, you might be glimpsing a cosmic Chladni plate in action. The universe doesn't just create order, it sings it into existence, one resonant frequency at a time. There's a number so elegant it's been called the fingerprint of the divine, 1.618, the golden ratio. You'll find it in the graceful swirl of a nautilus shell, the branching veins of a leaf, even the spiral arms of galaxies spinning millions of light years away. But this isn't just about aesthetics. The golden ratio represents something deeper, a harmonic bridge between mathematics, nature, and the very fabric of reality. Take music, where the ratio's proportions create intervals our brains perceive as perfectly balanced. A violin's body is often crafted to golden dimensions, resonating with richer tones. Architects from the Parthenon to Le Corbusier embedded this ratio into their designs, chasing an unconscious pull toward harmony. Even the human ear coils in a golden spiral, as if tuned to receive vibrations shaped by this universal constant. But here's where it gets cosmic. Some string theorists propose the golden ratio might govern the resonant frequencies of higher dimensions, the hidden geometry that could unite quantum mechanics and gravity. Look skyward and the ratio reappears. The Milky Way spiral arms unfurl at angles matching Fibonacci sequences, a mathematical cousin of the golden ratio. Distant galaxies cluster in proportions eerily close to 1.618, as if space itself favors this harmonic blueprint. Even time might dance to this rhythm. The pulses of some quasars, the universe's most energetic objects, flicker in golden-related intervals like a metronome set by cosmic design. Is this mere coincidence or evidence of a deeper resonance? Skeptics argue humans are pattern-seeking creatures, projecting meaning where none exists. Yet when quantum physicists model the vibrational modes of atomic nuclei, golden ratios emerge in their energy levels. DNA's double helix completes a turn every 34 angstroms, a Fibonacci number divisible by the golden ratio. From the infinitesimal to the infinite, this proportion threads through reality like a melody repeating across scales. Perhaps the most tantalizing idea is that the golden ratio isn't just a mathematical quirk, it's a signature. A hint that the universe composes itself through harmonic relationships, with vibration as its fundamental language. Whether scribbled in sunflower seeds or etched across galactic superclusters, this ratio whispers a truth we're only beginning to grasp: that chaos is an illusion, and beneath the surface, everything sings in perfect tune. Sprinkle fine powder onto a metal plate, send a pure tone vibrating through it, and watch something magical happen. Chaos becomes order. The particles don't scatter randomly. They cluster into intricate geometric shapes: circles, hexagons, even mandalas so precise they look designed. This is cymatics, the visible fingerprint of sound, and it's not just a parlor trick. It's a window into how vibrations might shape reality at every scale, from the swirl of cream in your coffee to the grand architecture of the cosmos. Ancient mystics seem to grasp this intuitively. Hindu scriptures describe creation as beginning with the sound Om, a primordial vibration that crystallized into matter. Tibetan monks used singing bowls to sculpt sand into sacred geometry, as if demonstrating a hidden truth. Sound doesn't just travel through matter, it organizes it. Fast forward to the 18th century, when Ernst Chladni first mapped these sonic patterns, proving that frequency could impose order on chaos. Today, we've gone further. Scientists use cymatics to study everything from cell membranes, which vibrate at specific frequencies to regulate what enters and exits, to the behavior of plasma in stars, where magnetic sounds sculpt solar flares into spirals. But here's where it gets cosmic. The same principles that arrange sand on a plate might govern the universe's large-scale structure. After the Big Bang, sound waves rippled through the seething plasma of the early cosmos, compressing matter into dense regions where galaxies would later form. Astronomers call these Baryon acoustic oscillations, but strip away the jargon, and it's essentially cymatics on a galactic scale: sound waves, leaving imprints in the distribution of matter, like a cosmic fingerprint frozen in time. Even now, black holes emit gravitational waves that ring space-time like a bell, their frequencies dictating how surrounding matter clusters. Down at the quantum level, the parallels deepen. Crystallographers have long known that exposing certain liquids to specific frequencies can trigger them to solidify into crystals with perfectly aligned structures. It's as if the sound whispers instructions to atoms, telling them where to settle. Some researchers speculate that DNA itself might rely on vibrational signals to repair mutations, with different base pairs resonating at distinct frequencies. If true, life's blueprint isn't just chemical, it's musical. So what does this mean for the big picture? If vibrations can turn chaos into geometry in a lab, could the universe itself be a kind of cymatic pattern, a vast, dynamic sculpture shaped by resonant frequencies? From the spin of electrons to the orbits of planets, everything moves in rhythms. Perhaps matter is just another word for music we can touch. And when you hum a tune or feel bass vibrate in your chest, you're not just hearing sound. You're witnessing the same force that might have woven the cosmos. Pythagoras stood under the star-strewn skies of ancient Greece, convinced the planets moved to silent harmonies, a celestial symphony he called the music of the spheres. For millennia, scholars dismissed this as poetic fancy, the wistful musings of a mathematician who heard numbers in everything. But fast forward to the space age and something extraordinary happened. Our probes didn't just photograph planets, they listened, and what they heard would have made Pythagoras smile. Take Jupiter, that swirling giant with storms larger than Earth. When NASA Juno spacecraft dipped into its magnetosphere, it detected something uncanny, eerie whistles and pops like radio static from a distant era. These aren't random noises, they're the result of charged particles spiraling along Jupiter's magnetic field lines, generating natural radio emissions. If you speed them up into the range of human hearing, they transform into something almost musical, a chorus of otherworldly chirps and hums. Scientists call them Jovian kilometric radiation, but strip away the jargon and it's Jupiter singing. Then there's Saturn, where the rings aren't just icy debris, they're composers. The Cassini spacecraft discovered that ring particles collide in rhythmic patterns, creating pressure waves that ripple through the planet's atmosphere. These waves resonate at specific frequencies, like the vibrations of a plucked string. Converted to sound, they produce haunting tones, as if Saturn's rings are strumming the fabric of space itself. Even Earth's magnetosphere has a voice, a low-frequency, dawn chorus of electromagnetic waves, akin to birds greeting the sunrise. What's revelatory isn't just that space makes noise, it's how structured these sounds are. The ancients imagined celestial harmonies as perfect mathematical ratios, and modern data reveals they weren't far off. The radio emissions from Jupiter's moons, for instance, follow predictable intervals like notes in a scale. Saturn's ring waves, they obey harmonic laws similar to those governing musical instruments. It's as if the solar system is an orchestra, with each planet contributing its own timbre and pitch. This convergence of myth and science raises a tantalizing question. Did ancient cultures intuit a truth we're only now measuring? Hindu texts describe the universe arising from sound, not a Brahma, while indigenous Australian songlines mapped landscapes to vibrational stories. Even Kepler, the father of planetary motion, clung to Pythagorean harmonics when plotting orbits, convinced geometry and music were twin languages of creation. Today, we're discovering he might have been onto something. The music of the spheres isn't metaphor, it's physics, yet the real magic lies in what we haven't heard yet. As telescopes grow more sensitive, we're detecting gravitational waves, ripples in space-time from colliding black holes, that can be transposed into sound. Some theorists speculate dark matter might vibrate at frequencies beyond our current instruments, a cosmic bassline waiting to be heard. The universe isn't silent, we're just learning to tune in. So the next time you gaze at the night sky, remember, those distant worlds aren't just spinning, they're singing. And after centuries of skepticism, science is finally catching up to the poets. Nikola Tesla stood in his Colorado Springs laboratory in 1899, convinced he'd tapped into something primordial. As his massive electrical coils thundered with artificial lightning, the ground itself seemed to hum beneath his feet. To onlookers, it was just another of Tesla's audacious experiments, but the inventor knew better. He wasn't just generating sparks, he was conducting the universe. Tesla's notebooks reveal a startling belief. That vibration wasn't merely a property of matter, but the hidden scaffold of reality itself. While mainstream science of his era focused on particles and forces, Tesla saw resonance as the master key, a principle that could explain everything from wireless energy transmission to planetary motions. His most controversial experiments involved mechanical oscillators, devices designed to vibrate at precise frequencies. Legend claims one test allegedly shook buildings blocks away, leading to exaggerated tales of earthquake machines. The truth was more nuanced but no less revolutionary. Tesla had discovered that striking an object's resonant frequency could amplify small inputs into massive outputs, a principle now fundamental to everything from MRI machines to seismic studies. His intuition about Earth's natural frequencies later found validation in the Schumann resonance's electromagnetic waves bouncing between our planet's surface and ionosphere like a global tuning fork. What made Tesla's vision extraordinary was its scope. He imagined the cosmos as a vast network of interconnected vibrations, where energy could leap between points not through wires but through harmonic sympathy. Modern physics has since uncovered eerie parallels. Take Elfvane waves, magnetic ripples coursing through plasma in Earth's magnetosphere, and even between galaxies. These cosmic vibrations behave exactly as Tesla predicted, energy propagating not linearly, but through resonant transfer, like a tuning fork triggering another across a room. Even quantum entanglement, where particles instantly influence each other across distances, finds suggestive echoes in Tesla's belief that vibration could bridge space instantaneously. Yet Tesla's legacy is a double-edged sword. While some dismissed him as a mystic, others now recognize how his vibrational worldview anticipated cutting-edge concepts. String theory's vibrating filaments, Tesla spoke of standing waves structuring matter, wireless power transmission. His Wardenclyffe Tower aimed to harness Earth's natural frequencies, an idea reborn in proposals to beam energy via microwave resonances. Even his fascination with 3, 6, and 9 as sacred numbers finds quirky parallels in the three-dimensional nature of wave propagation and hexagonal patterns in cymatics. The lesson isn't that Tesla had all the answers, but that his vibrational lens revealed truths orthodox science took decades to rediscover. When researchers today detect gravitational waves or map quantum fluctuations, they're continuing the work he began, probing a universe that doesn't just contain vibrations, but may fundamentally be vibration. Tesla's genius lay in recognizing what poets and physicists now agree on: that existence isn't static but a dynamic, singing tapestry, one we're only beginning to hear. Close your eyes and imagine two tuning forks struck simultaneously, one humming at 140 Hz, the other at 144. Your brain does something remarkable. It perceives a third tone pulsing at 4 beats per second, a phantom rhythm born from the interference between them. These are binaural beats, auditory illusions that reveal more than a quirk of perception. They unlock a profound truth about our minds, that human consciousness isn't isolated, but deeply responsive to the vibrational world around it. This phenomenon, called the frequency-following response, shows how external rhythms can steer our brainwaves like a conductor guiding an orchestra. When headphones deliver binaural beats in the alpha range 8 to 12 Hz, listeners often slip into relaxed meditative states. Theta frequencies, slower and deeper, may enhance creativity or sleep. It's as if the brain surrenders to the rhythm, tuning its own electrical symphony to match the external pulse. Ancient cultures seem to intuit this connection, using drumming and chanting to shift awareness long before neuroscience confirmed their power. But here's where it gets cosmic. If simple audio tones can alter consciousness, could the universe's own vibrations, those deep hums of gravitational waves, the resonant frequencies of planets, also nudge human minds? Some researchers speculate that Earth's Schumann resonances, electromagnetic waves pulsing between 7.83 Hz and beyond, might subtly influence brain function. Studies show that isolating humans from these natural frequencies can disrupt circadian rhythms and cognition, as if we're unknowingly attuned to our planet's heartbeat. Expand the lens further and wilder theories emerge. Could the resonant frequencies of black holes or neutron stars, events we now detect as gravitational waves, have shaped early life's evolution? Philosophers like Carl Jung pondered the collective unconscious, a shared mental fabric that might mirror the universe's interconnected vibrations. Even modern quantum biology suggests that microtubules in brain cells could vibrate at frequencies influenced by cosmic phenomena, bridging individual thought with universal resonance. Yet this isn't mysticism, it's frontier science. Laboratories now use transcranial magnetic stimulation to play specific frequencies directly onto the brain, treating depression and enhancing memory. If technology can harness vibrations' power so precisely, might nature have been doing the same all along? From the rhythmic crashing of ocean waves to the resonant frequencies of ancient megaliths like Stonehenge, humans have always sought harmony with vibrational environments. Perhaps the most humbling realization is this: when you meditate to binaural beats or lose yourself in music, you're not just listening. You're participating in the same dance of resonance that shapes galaxies, a fleeting alignment between the rhythms of mind and cosmos. Whether by accident or design, we're vibrational beings in a vibrational universe, forever echoing each other's songs. We think of dark matter as the universe's silent partner, an invisible presence that outweighs visible matter 5 to 1. Its gravity sculpting galaxies into being without so much as a whisper. But what if it's not silent at all? What if dark matter hums, vibrating at frequencies so subtle we've yet to tune our instruments to hear it? The latest theories suggest this cosmic phantom might be singing in a register beyond our current perception, its notes woven into the fabric of reality itself. Take actions, one of the leading candidates for dark matter particles. These hypothetical entities are thought to be unimaginably light, possibly 1 trillion times less massive than an electron. And if they exist, they'd behave less like discrete particles and more like waves rippling through space. Quantum mechanics tells us all particles have wave-like properties, but actions would take this to an extreme, oscillating at specific frequencies as they interact with magnetic fields. Picture the world's quietest tuning fork, vibrating in the dark for billions of years. That's the action's proposed signature, a faint, persistent hum resonating across the cosmos. Scientists aren't just speculating, they're listening. Deep underground, shielded from cosmic noise, experiments like the Action Dark Matter experiment, atoms use powerful magnetic fields and ultra-sensitive detectors to hunt for these elusive vibrations. It's akin to tuning a radio dial through static, searching for one barely audible station amid the hiss. Atoms' superconducting cavity acts like a resonant chamber, designed to ring if an action of the right frequency passes through, converting its vibration into a detectable microwave photon. The challenge: actions could be humming at any frequency across a vast range, making the search like finding a needle in a galactic haystack, yet the payoff would redefine physics. Detecting dark matter's vibration wouldn't just solve one of science's greatest mysteries, it could reveal an entire hidden layer of the universe's symphony. Some models suggest actions might interact with ordinary matter only through resonance, meaning everything around us, including us, might be subtly swaying to their rhythm without realizing it. Even wilder, certain theories propose that action vibrations could warp space-time on microscopic scales, creating fleeting pockets where the laws of physics bend slightly. It's as if the universe has been playing a duet all along, with dark matter humming the harmony just beneath our notice, and actions aren't the only players in this chorus. Other dark matter candidates, like weakly interacting massive particles WIMP, might also generate vibrational signatures through quantum interactions. Or consider fuzzy dark matter, a model where ultra-light particles form wave-like halos around galaxies, their interference patterns potentially detectable as faint ripples in starlight. Each hypothesis offers a different musical note in the dark matter scale, waiting to be heard. What's truly exhilarating is how this quest mirrors humanity's oldest intuitions. Ancient cultures from the Maya to the Vedic seers describe the cosmos as vibrational at its core, a concept modern physics now echoes with equations instead of myths. Whether ADMX or some future experiment catches dark matter's hum, the implication is profound. We're not just observers of the universe's music, we're surrounded by its full composition, with whole movements still waiting to be heard. The silence of dark matter might just be a matter of frequency, and we're finally learning to listen. Every second, trillions of invisible particles sail through your body like cosmic ghosts, neutrinos, so elusive they can pass through light years of lead without a single collision. But here's the twist: these phantoms aren't just silent spectators. They're shape-shifters oscillating between three distinct flavors: electron, muon, and tau, as they race through space at near light speed. This quantum waltz, called neutrino oscillation, isn't just a curious particle quirk. It's a seismic revelation that cracked open the standard model of physics, proving these ghostly particles carry mass when we once thought they weighed nothing at all. Picture a chameleon mid-stride, its colors flickering between red, blue, and green with every step. That's essentially what neutrinos do, except their colors are quantum states, and the steps span entire galaxies. When scientists first detected this phenomenon in experiments like Super Camiok, and it sent shockwaves through physics, the math said neutrinos should be massless, yet their oscillations demanded otherwise. It was like discovering a violin could change its pitch mid-note without the musician touching the strings, a violation of cosmic harmony that forced us to rewrite the rules. But the real magic lies in what neutrino oscillations imply about the universe's hidden vibrations. Each time a neutrino shifts flavor, it's not just changing identity, it's vibrating through quantum fields, sending ripples through the fabric of reality. Multiply that by the countless neutrinos streaming from the sun, supernova, and even the Big Bang's afterglow, and you've got a universe thrumming with their collective rhythm. Some theorists speculate these oscillations could contribute to dark energy's repulsive force, or even influence large-scale structures like galactic filaments through subtle gravitational nudges. Then there's the eerie parallel to sound. Just as musical notes interfere to create beats, those pulsating rhythms, when two tones are slightly out of sync, neutrino oscillations arise from quantum interference between mass states. It's as if each neutrino carries its own silent melody, with flavors emerging from the harmonies and dissonances of its underlying vibrations. When a supernova explodes, the neutrinos it emits arrive at Earth in a staggered chirp, their oscillations encoding secrets about the star's core that light alone could never reveal. What's most humbling is how these ghostly particles connect us to the cosmos. The neutrinos passing through you right now include relics from the universe's first seconds, oscillating unchanged since the dawn of time. Others might be streaming from a black hole's accretion disk halfway across the universe, their flavors shifting like whispers in a cosmic game of telephone. They remind us that even in the emptiest void, vibration reigns, from the quantum jitter of particles to the resonant hum of galaxies. The universe doesn't just play its symphony to an audience. It sings through us, one neutrino at a time. Plasma isn't just the fourth state of matter. It's the universe's most prolific artist, painting filaments of glowing gas across the cosmos with strokes of electromagnetic energy. Picture a lightning storm frozen in space, stretched to galactic scales, and you begin to grasp plasma cosmology's radical vision. This controversial framework suggests that 99% of the visible universe, nebulae, stars, even the vast webs connecting galaxies is sculpted not by gravity alone, but by electric currents coursing through ionized gas. At its core lies a symphony of resonance, where plasma vibrates in harmony with electromagnetic fields, creating structures so eerily similar to laboratory experiments that it forces us to reconsider everything we thought we knew about cosmic design. In the lab, plasma behaves like a living thing, subjected to electrical currents, and it spontaneously forms twisting filaments, rotating spirals, and glowing double-layer structures that mirror the shapes of distant galaxies and nebulas with uncanny precision. The famous plasma Z-pinch experiment, where currents cause plasma to collapse into braided columns, produces patterns indistinguishable from Hubble images of galactic jets. When researchers pass alternating currents through plasma, it self-organizes into concentric shells, mimicking the layered structure of supernova remnants. These aren't just visual coincidences. The math governing plasma's behavior in the lab scales up shockingly well to astrophysical phenomena, suggesting electromagnetic resonance might be the invisible hand shaping the cosmos. Mainstream astrophysics traditionally downplays large-scale electric fields in space, assuming plasma is quasi-neutral over vast distances, but plasma cosmology's proponents point to anomalies that defy this view. The discovery of billion light-year-long magnetic fields threading the cosmic web, the precise alignment of galactic spins along these filaments, even the unexpected Whistler waves detected in interstellar plasma, all hint at electromagnetic organization on scales once thought impossible. Then there's the Sun's corona, mysteriously hotter than its surface, which some plasma researchers attribute to resonant heating from alternating currents rather than traditional shockwave models. The most striking parallel to harmonic cosmology lies in plasma's inherent musicality. Just as a violin string vibrates at specific harmonics, plasma supports distinct wave modes: Alfvén waves, magnetosonic waves, Langmuir waves, each propagating at characteristic frequencies. When these vibrations interact, they create interference patterns that could explain the periodic spacing of galaxies and the fractal-like distribution of matter. Some plasma cosmologists go further, suggesting that the universe's large-scale structure isn't a fossilized echo of the Big Bang's sound waves, but an ongoing electromagnetic symphony, with plasma filaments acting as cosmic strings vibrating in the magnetic fields of space. Skeptics rightly note that plasma cosmology struggles to explain phenomena like the cosmic microwave background's precise blackbody spectrum or the abundance of light elements cornerstones of Big Bang theory. Yet even critics admit that electromagnetic forces are likely underestimated in modern astrophysics. The truth may lie in synthesis, gravity building the cosmic scaffold, while electromagnetic resonance fine-tunes its details. After all, both frameworks ultimately describe vibration, whether as space-time ripples or plasma oscillations as cosmic architect. What makes plasma cosmology compelling isn't just its alternative explanations, but its reminder that the universe communicates through frequency. From the resonant vibrations of quantum strings to the electromagnetic hum of galactic filaments, reality seems obsessed with harmony. Whether you view plasma cosmology as revolutionary or fringe, its central insight resonates. The cosmos doesn't just contain music, it is music, written in the language of vibrating fields and charged particles. And that's a chord that strikes deep, no matter which theory you tune into. Fractals are nature's fugue, a melody that repeats itself from the microscopic to the cosmic, each iteration a variation on the same harmonic theme. Look at a jagged coastline from space, and you'll see the same irregular contours in the branching veins of a leaf or the lightning-forged tendrils of a Lichtenberg figure. Zoom in on a cloud's edge, and its turbulence mirrors the swirling arms of a distant galaxy. These aren't just visual echoes, they're evidence of a deeper vibrational logic, a resonance that scales infinitely, binding the universe together in a symphony of self-similarity. When mathematician Benoit Mandelbrot first mapped fractal geometry, he uncovered something startling. The same equations that described the jaggedness of a fern's frond also modeled the clustering of galaxies and the fluctuations in the cosmic microwave background. It was as if the universe had a signature vibration, a rhythmic pattern that repeated whether you were observing quantum foam or superclusters spanning millions of light years. Take the Mandelbrot set, that iconic fractal where every zoom reveals new complexity within its infinite boundary. Now imagine the cosmos as a grand cosmic Mandelbrot, with vibrations resonating not just in isolated pockets, but across every conceivable scale, from the hum of electrons to the gravitational waves of colliding black holes. This fractal harmony isn't just aesthetic, it's functional. In the human body, the bronchial branches of the lungs maximize surface area through fractal splitting, allowing oxygen to resonate efficiently with blood vessels. Similarly, the universe's large-scale structure, filaments of galaxies woven into a cosmic web, follows fractal distributions, as if space itself were breathing in rhythmic, recursive patterns. Even time might fractalize. Solar flares and heartbeat intervals exhibit fractal fluctuations, suggesting vibration isn't just a spatial phenomenon, but a temporal one, with rhythms nested within rhythms like a Russian doll of resonance. The most tantalizing implication: if the universe is fundamentally fractal, then its vibrations might obey a kind of musical recursion. A quark's quantum spin could resonate in harmony with the rotation of a star system, which in turn echoes the spiral of an entire galaxy. String theory's vibrating filaments might be fractal notes, playing the same theme across dimensions. Some researchers even propose that dark matter's elusive distribution could follow fractal mathematics, its hidden vibrations organizing the visible cosmos like an unseen conductor. What's breathtaking is how this mirrors ancient spiritual concepts. Hindu cosmology describes the universe as a fractal. As is the macrocosm, so is the microcosm. Indigenous creation stories speak of worlds within worlds, each vibrating to the same sacred pulse. Modern physics now quantifies these intuitions, revealing a cosmos where scale is an illusion and vibration is the connective tissue. Whether you're listening to the resonant frequencies of a vibrating crystal or the gravitational echoes of merging neutron stars, you're hearing the same song played on different instruments, but unmistakably part of the same score. The universe doesn't just contain music, it is music endlessly repeating, infinitely varied, and always harmonizing with itself. Imagine a snowflake that doesn't just repeat its pattern in space, but in time, a structure that pulses rhythmically without ever winding down, like a clock with no batteries yet never stopping. This isn't science fiction, it's the mind-bending reality of time crystals, a new phase of matter that dances to the universe's deepest rhythms. Unlike ordinary crystals, think diamonds or quartz whose atoms are arranged in repeating spatial patterns. Time crystals break the ultimate symmetry. They're structures that repeat their configurations not just in space, but in time itself. Picture a diamond that doesn't just sit on your finger, but pulses like a heartbeat, its atomic lattice oscillating perpetually without energy, input, a feat that defies everything we thought we knew about thermodynamics. The discovery of time crystals sent shockwaves through physics because they shouldn't exist. Classical physics insists perpetual motion is impossible. Energy gets lost to friction, systems wind down. Yet in 2016, Nobel laureate Frank Wilczek's theoretical musings became reality when labs created the first time crystals using chains of ytterbium ions or diamond flaws, coaxing them into stable, self-repeating quantum states. These systems don't violate energy conservation. Instead, they exploit quantum entanglement to tick like atomic metronomes, flipping between states in a loop that echoes across time. It's as if you plucked a guitar string once and it kept vibrating forever, its harmonics locked in an eternal refrain. Now, stretch this concept to cosmic scales. Deep inside neutron stars, those ultra-dense corpses of dead suns, conditions are so extreme that atomic nuclei get crushed into exotic quantum soups. Some physicists speculate time crystals could form naturally here, where gravity and quantum forces twist matter into phases we've never seen on Earth. Even black holes, those enigmatic voids, might harbor time crystalline structures in their turbulent accretion disks or at their event horizons, where space and time warp beyond recognition. If true, the universe isn't just filled with vibrations, it's humming with rhythms that repeat across time itself, like a cosmic record skipping on the groove of reality. What's truly revolutionary is how time crystals blur the line between matter and music. A violin string's vibration creates a note. A time crystal's oscillation might create a moment, a beat in the fabric of time. This hints at something profound, that time isn't just a backdrop for events, but an active participant, structured and harmonic. Ancient philosophies described time as cyclical, the wheel of samsara, the repeating ages of Mayan cosmology. Modern physics now whispers they might have been onto something. Time crystals suggest reality could be less like an arrow flying forward and more like a spiral, with rhythms nested within rhythms. The implications ripple outward. If time has structure, could we one day encode information in its vibrations, building quantum computers that process data in time's repeating patterns? Might the universe's expansion and contraction, if it cycles eternally, leave time crystalline echoes in the cosmic microwave background? Even consciousness, with its rhythmic brainwaves and perception of time's flow, might someday be understood through this lens. Time crystals don't just challenge physics, they invite us to hear reality as a composition where matter, energy, and time aren't separate notes, but chords in a grand, resonant harmony. The universe has always sung, now we're learning it dances too. Deep in a darkened lab, a scientist fills a flask with water and blasts it with high-frequency sound waves. At first, nothing seems unusual until microscopic bubbles form in the liquid, collapsing with such violence they emit sudden, brilliant flashes of blue light. This is sonoluminescence, one of physics' most enchanting mysteries, the alchemy of sound turning directly into light. Each imploding bubble concentrates the energy of acoustic vibrations into a fleeting, star-hot point, a process so efficient it defies classical thermodynamics. For a fraction of a microsecond, conditions inside those bubbles rival the surface of the sun, with temperatures exceeding 20,000 degrees Kelvin. Yet the container stays cool to the touch, as if the laws of energy have been momentarily bent. The parallels to cosmic phenomena are uncanny. Just as sonoluminescence squeezes sound into light, the universe may harbor similar vibrational transformers on a grand scale. Take pulsars spinning neutron stars that beam radiation like interstellar lighthouses. Their precise electromagnetic pulses aren't just emitted, they're generated through resonant interactions between the star's crushing gravity and its magnetosphere, converting rotational energy into focused light. Or consider quasars, where supermassive black holes funnel spiraling plasma into jets that glow across billions of light years. The mechanism, magnetohydrodynamic vibrations, cosmic sound waves, accelerating particles to near light speeds until they scream across the spectrum as radiation. Even the vacuum itself might hum with analogous energy conversions. Quantum field theory suggests that so-called empty space crackles with virtual particles popping in and out of existence, their brief lives governed by vibrational fluctuations. Some models propose that under extreme conditions like near a black hole's event horizon, these quantum vibrations could amplify into detectable light, a sort of universal sonoluminescence powered by gravity's roar rather than sound. It's as if nature has a playbook for turning vibration into illumination, written once at the quantum scale and echoed magnificently across galaxies. What's revelatory isn't just the similarity of mechanisms, but their implication. Vibration isn't merely a property of the universe, it's a currency. Energy sloshes between forms, from the mechanical pulse of a sound wave to the electromagnetic shimmer of light, because at some fundamental level, all might be expressions of a deeper, unified oscillation. Ancient alchemists dreamed of transmuting base metals into gold. Modern physics reveals a cosmos that continually transmutes motion into light, sound into stars, and vibration into the very fabric of reality. Experiments now push sonoluminescence further, probing whether collapsing bubbles might even fuse atomic nuclei, mimicking the heart of stars. If proven, it would mean a simple sound wave in water could unlock nuclear processes, a testament to vibration's transformative power. From lab flasks to galactic cores, the message resonates. The universe doesn't just move, it sings, and in singing, it shines. The holographic principle turns reality inside out, literally. Imagine the universe as a cosmic movie screen, where the three-dimensional world we experience is just a projection from information encoded on a distant two-dimensional surface. It's like watching a hologram on a credit card, tilted, and the flat sticker creates an illusion of depth. But here, the sticker is the edge of the known universe, and the hologram is everything: stars, galaxies, even your own hands. This isn't science fiction, it's a serious theory emerging from black hole physics, suggesting that vibration might be the ink with which reality is written. The idea took root when physicists studying black holes hit a paradox. These cosmic voids swallow information irretrievably, or so it seemed, but quantum mechanics insists information can't be destroyed. The breakthrough came when researchers realized a black hole's event horizon, the point of no return, could encode all the information about what fell inside, not in its volume but on its surface. Like a cosmic hard drive, the horizon vibrates with microscopic quantum bits, storing data in patterns reminiscent of a hologram's interference fringes. Scale this up, and the entire universe might work the same way. A three-dimensional illusion projected from vibrations on a two-dimensional boundary we can't see or touch. If true, this reshapes what real even means. Think of a vinyl record. The music isn't in the grooves themselves, but in the vibrations they create when the needle moves. Similarly, space-time might be the needle, translating vibrational data from the universe's edge into the richness of our experience. Even gravity could emerge from these underlying vibrations, like the resonant hum of a plucked string, creating the illusion of force. This would mean the cosmos isn't just filled with vibrations, it's made of them, a dynamic projection where matter and energy are notes in a grand, dimensional composition. The wildest implication, if the holographic principle holds, we're all vibrational phantoms, complex interference patterns in a cosmic hologram. Your thoughts, the feeling of sunlight on your skin, even the vast emptiness between galaxies would be vibrations rendered in 3 dimensions. Some theorists take it further, suggesting that if we could decode the universe's boundary vibrations, we might find the equations of reality written in a language of frequency and resonance. It's a vision that unites black holes, quantum mechanics, and the nature of existence itself under one stunning premise: that the universe isn't just playing music. It is music, an eternal symphony performed on the strings of dimensionality. The human brain hums with electricity, not random noise, but rhythmic pulses that dance in precise synchrony. When neuroscientists peer inside with EEG machines, they don't see chaos, they detect waves. Alpha waves ripple through your cortex when you daydream, theta waves when you dream at night, and gamma waves when sudden insight strikes. These aren't just byproducts of thought, they might be thought itself. A radical hypothesis gaining traction suggests consciousness isn't something the brain has, but something it does. A symphony of resonant frequencies where synchronized neurons create self-awareness the same way vibrating strings create a chord. Consider the binding problem, the puzzle of how scattered brain regions unite into a single, seamless experience. When you see a red apple, distinct areas process its color, shape, and memory, yet you perceive it as one object. The answer might lie in neural oscillations synchronizing across regions, like musicians in an orchestra tuning to the same pitch. Experiments show that when gamma waves around 40 Hz sync across distant brain areas, subjective awareness emerges. Disrupt these vibrations with magnetic pulses and consciousness flickers. It's as if the mind is a standing wave, a pattern of interference where resonance becomes experience. Now stretch this idea to its logical extreme. If consciousness arises from vibrations in the brain, could the same principle apply to other vibrating systems? Panpsychism, the controversial view that all matter possesses some rudimentary form of consciousness, proposes exactly this. From the rhythmic spin of electrons to the resonant frequencies of crystals, perhaps proto-awareness isn't a binary switch but a spectrum of vibrational complexity. The universe wouldn't just contain consciousness, it would be consciousness expressed in infinite variations like notes on a cosmic scale. Evidence lurks in unexpected places. Slime molds, brainless, single-celled blobs exhibit decision-making by oscillating their internal chemistry, effectively voting via rhythmic pulses. Plants communicate through bioelectrical waves that some researchers compare to neural activity. Even atoms, with their electron orbitals vibrating at precise frequencies, display a kind of proto-choice when quantum probabilities collapse into definite states. These aren't metaphors, they're behaviors that mirror, however faintly, the resonant origins of human awareness. The implications are staggering. If consciousness is vibrational, then the boundary between mind and matter blurs. A black hole's event horizon vibrates with quantum information. Does it harbor some dim echo of perception? Do stars, pulsing with acoustic oscillations, experience a slow, nuclear-grade awareness? The idea seems outlandish until you realize that your own thoughts might be no different, just vibrations organized into meaning. Perhaps the most haunting possibility is this: if the universe vibrates universally, then reality might not just be playing music. It might be listening to itself, an infinite resonance reflecting back upon itself in an eternal loop of perception. Your awareness, then, isn't an accident, it's the universe hearing its own song through the fragile instrument of your brain. Watch two pendulum clocks hanging side by side within hours, their swings synchronized, ticking in perfect unison. This eerie coordination, called entrainment, isn't magic. It's physics revealing one of nature's deepest secrets. The universe craves harmony. From the quantum realm to galactic superclusters, systems don't just interact, they fall into rhythm, as if the cosmos is a grand conductor ensuring every instrument plays in time. Take Jupiter's moons, Europa and Ganymede. For every orbit Ganymede completes, Europa circles twice, locked in a gravitational waltz so precise it could keep cosmic time. These orbital resonances aren't accidents. They're the universe's way of minimizing chaos, allowing celestial bodies to exchange energy until their motions become mathematically intertwined. Even Saturn's rings, those dazzling bands of ice and dust, are sculpted by resonances with its moons. Like a needle skipping grooves on a record, the moon's gravity carves gaps and waves into the rings, turning raw material into celestial art. But entrainment isn't confined to our solar system. Across the universe, galaxies pirouette in clusters, their rotations subtly syncing over billions of years like dancers feeling each other's tempo. Astronomers call this dynamical friction, a poetic term for how galaxies nudge each other into harmony, their dark matter halos whispering gravitational cues until their spins align. Even stars within galaxies entrain, their orbits collectively shaping the grand spiral arms we admire from afar. Zoom in, and the pattern persists, fireflies in a meadow blink in unison. Cardiac cells pulse in rhythm to keep your heart beating. The human brain's neurons synchronize during deep focus or meditation, as if tuning into some silent metronome. At every scale, from cells to superclusters, systems lean toward synchronization, drawn by an invisible pull toward order. What's astonishing is how this mirrors quantum entanglement, where particles instantaneously mirror each other's states across vast distances. Though separated by light years, they vibrate as one, hinting that entrainment might be written into the fabric of reality itself. Some theorists propose that the universe's tendency to sync up isn't incidental, it's foundational, a consequence of vibration being the substrate of all things. So the next time you see leaves rustling together in the wind or hear a crowd's applause coalesce into a steady clap, you're glimpsing a cosmic truth. Entrainment isn't just a curious phenomenon. It's evidence that the universe, for all its apparent chaos, is a symphony searching for its perfect chord. And every atom, every star, every spinning galaxy is listening. The silence of the cosmos isn't just puzzling, it's deafening. If the universe truly vibrates with harmonic potential, where are the orchestras of alien civilizations? Enrico Fermi's famous question, "Where is everybody?" takes on a haunting new dimension when viewed through the lens of resonance. We've spent decades scanning the skies for radio signals, listening for the cosmic equivalent of a shouted hello. But what if advanced societies aren't broadcasting in wavelengths we can easily detect? What if they're conducting symphonies in the key of gravity itself, using the fabric of space-time as their medium? Consider gravitational waves, ripples in reality that only recently became detectable to our crude instruments. An advanced civilization might have mastered the art of modulating these space-time vibrations, encoding information in the ringing aftermath of colliding neutron stars or the resonant frequencies of artificial black holes. Imagine receiving a message not through crackling radio static, but through the subtle warping of space-time itself, a cosmic Morse code written in the stretching and squeezing of the universe's very geometry. The LIGO Observatory has already shown us that space rings like a bell when massive objects collide. Who's to say some civilization hasn't learned to play that bell with intention? Then there's quantum vibration. At the smallest scales, particles remain mysteriously connected through entanglement, instantly mirroring each other's states across vast distances. While we struggle to maintain quantum coherence in our primitive quantum computers, an older civilization might have perfected quantum communication, networks sending perfectly synchronized vibrations between stars without any physical signal traversing the space between. Their radio stations could be entangled particles humming in unison across light years, creating a web of instantaneous connection that makes our electromagnetic broadcasts look like smoke signals. Perhaps the most poetic possibility is that we're surrounded by alien art we can't yet perceive. Just as ultraviolet patterns on flowers guide bees invisible to human eyes, the galaxy might be pulsing with resonant masterpieces we lack the senses to appreciate. Dark matter's elusive vibrations could be the canvas for civilizations that learn to sculpt gravitational potentials like artists shaping clay, the mysterious fast radio bursts that puzzle astronomers. They might be the equivalent of a child's first piano scales compared to the interstellar concertos vibrating just outside our detection range. This harmonic twist on the Fermi paradox doesn't just suggest we're listening for aliens the wrong way. It implies we might be missing an entire vibrational ecology. The same resonances that structure galaxies and quantum foam could be the natural language of advanced intelligence, a universal communication channel far more efficient than electromagnetic waves. Until we expand our sensory palette to include the full spectrum of cosmic vibrations, we're like deaf observers at an opera, wondering why the performers' mouths move but no sound emerges. The silence isn't empty, we're just not tuned to the right frequency. Deep within the limestone chambers of Malta's hypogeum, a burial site carved 5,000 years ago, something extraordinary happens. Speak or chant at a certain pitch, and the entire room transforms into a resonant cavity, amplifying the sound with such eerie clarity it feels supernatural. This isn't accidental architecture. Across the globe, from the subterranean temples of Peru to the towering stones of Karnak in France, ancient builders constructed monuments that don't just withstand time, they sing with it. Acoustics, the study of how prehistoric sites interact with sound, reveals that these spaces weren't merely shelters or shrines. They were instruments carefully tuned to frequencies that alter human perception. Take Chavin de Huanta in the Peruvian Andes. Its labyrinthine corridors and ventilation shafts channel wind into haunting tones, while the central monolith, the Lanzon, resonates at 111 Hz, a frequency known to induce trance states in modern brainwave studies. At Ireland's Newgrange, a passage tomb older than the pyramids, the corbelled ceiling acts like an acoustic filter, amplifying only certain vocal tones while dampening others. The effect, chants or drum beats, would have reverberated with spine-tingling precision, turning rituals into multisensory experiences where sound physically vibrated through bone and stone alike. What's startling is how these frequencies align with natural human responses. Modern experiments show that 110 to 112 Hz, the range many ancient sites amplify, shifts brain activity from beta to alpha waves, a state linked to meditation and heightened suggestibility. It's as if Neolithic engineers discovered psychoacoustics millennia before the invention of the stethoscope. Some researchers speculate these cultures used resonance the way we use anesthesia, a vibrational technology to alter consciousness, ease pain, or commune with the unseen. The implications ripple beyond archaeology. At Stonehenge, laser scans revealed that the bluestones hauled 240 kilometers from Wales have unusual acoustic properties. When struck, they ring with metallic tones similar to bells or gongs, suggesting the monument might have been a colossal lithophone. Meanwhile, Maya pyramids like Kukulkan at Chichen Itza produce chirping echoes mimicking the sacred Quetzal bird when you clap at their base, an effect so precise it's statistically impossible to be coincidental. These aren't parlor tricks, they're evidence of cultures that understood sound as a shaping force, wielding resonance to bridge earth and sky, body and spirit. Perhaps the most tantalizing thread connects these ancient practices to harmonic cosmology. If modern physics sees the universe as a web of vibrations, from quantum strings to galactic oscillations, were these early builders tapping into the same principles? The Vedas described cosmic sound creating matter, Aboriginal songlines mapped landscapes to vibrational stories. Now, quantum biologists find proteins in our cells vibrate at specific frequencies to trigger healing. The gap between ancient intuition and cutting-edge science narrows to a whisper. That resonance isn't just a tool, but a foundational language, one these cultures spoke fluently, and we're only now relearning. Standing in these sites today, the stones seem to hum with unspoken knowledge. They challenge our assumptions about primitive technology, suggesting lost sciences where architecture, acoustics, and astronomy intertwined. Maybe the ancients didn't just build monuments, they composed symphonies in stone, orchestrating vibrations that still echo with questions. What did they know about the universe's song that we've yet to rediscover? The stones hold the notes, we're only beginning to hear them. Every time your heart beats or a thought flickers through your mind, your body does something extraordinary. It emits light. Not the warm glow of a lamp, but ultra-faint pulses called biofotons, whispers of photons radiating from your cells at a rate so subtle it takes ultra-sensitive detectors to spot them. These aren't random sparks. They're rhythmic, coherent emissions. Some scientists believe they form a hidden communication network inside living things, a vibrational language that might orchestrate everything from wound healing to consciousness itself. Picture a firefly's flicker, but scaled down to the cellular level. When DNA repairs itself, when neurons fire, even during embryonic development, cells release these biophotons in patterns that mirror the precise frequencies of their metabolic processes. Experiments show that onion roots grow faster when exposed to light from other onion roots, as if the plants are trading photonic signals. Human cells in Petri dishes synchronize their division rates when separated by quartz glass, which transmits light, but not by opaque barriers. It's as if life evolved to harness light, not just for photosynthesis or vision, but as an invisible drumbeat coordinating biology's most intimate dances. Now stretch this idea to cosmic proportions. If biophotons help synchronize cells, could the universe use similar vibrational rules to organize galaxies? The parallels are uncanny. Just as cells emit coherent light, stars and quasars broadcast electromagnetic signatures across the cosmos. The same quantum principles governing photon interactions in your retina might also dictate how light resonates between celestial bodies. Some researchers, like biophysicist Fritz Albert Popp, propose that biophotons aren't just biological static. They're part of a larger vibrational matrix, a bridge between quantum processes in our bodies and the resonant fields threading the universe. The implications ripple outward. Traditional medicine often dismisses concepts like energy healing, but biophoton research lends credence to ancient systems like acupuncture. Measurements reveal spikes in photon emissions along meridian points when needles are inserted, as if tapping into an invisible circuit. Even meditation's physiological effects might have a photonic component. Advanced practitioners show unusual biophoton coherence, their cells humming in harmony like a tuned orchestra. But the most profound idea lies in scaling. If cells communicate through vibrations and galaxies interact through resonant frequencies, could consciousness itself be a kind of standing wave in this universal symphony? Quantum biologists speculate that microtubules in brain neurons might vibrate at frequencies that interface with broader cosmic oscillations, blurring the line between thought and the universe's own hum. Your body doesn't just exist in the cosmos, it resonates with it, a microcosm of the same vibrational logic that spins electrons and stars alike. So the next time you feel a sudden sense of connection under a starry sky, consider this: the light in your eyes and the light from those distant suns might be more than poetic siblings. They could be notes in the same endless song, vibrations across scales, binding you to everything that pulses, spins, or shines. quantum entanglement plays out like the universe's most intimate duet, two particles separated by galaxies, yet moving in perfect, inexplicable sync. Imagine tossing a pair of gloves into deep space, one to Mars and the other to Pluto. Open the Martian glove to find it's left-handed, and instantly, without signal or delay, you know its twin light-years away is right-handed. This isn't just a quirky analogy. It's the baffling reality Einstein famously dismissed as spooky action at a distance. But what if this spookiness isn't action at all? What if entangled particles aren't communicating but resonating, bound by vibrations that bypass space-time entirely? At the heart of this mystery lies a radical idea. Entanglement might be the universe's way of maintaining harmony at the quantum scale. When particles become entangled, they don't just share states, they share a vibrational identity, like two tuning forks humming the same pitch even when placed in separate rooms. Experiments with photons, electrons, and even tiny diamonds chilled to near absolute zero show this synchronization holds across any distance, defying the cosmic speed limit of light. The implications are staggering. If vibration can link particles faster than light, then the fabric of reality might be woven with threads that don't play by classical rules. Some theorists propose these connections operate through hidden dimensions, where vibrations propagate unseen, like sound traveling through walls we can't perceive. Others suggest entanglement reveals a deeper truth that space-time is emergent, a secondary phenomenon arising from a more fundamental layer of resonant quantum fields. Picture the universe as a grand symphony where what we call distance is merely the space between notes, not an obstacle to their harmony. In this view, entangled particles aren't breaking the rules, they're revealing the score behind the illusion. The most mind-bending possibility, entanglement might not be rare but ubiquitous, with every particle in the universe subtly vibrating in tune with countless others. Just as air molecules carry sound waves we don't consciously hear, the quantum vacuum could be thrumming with entanglement's silent chords, connecting everything from the electrons in your brain to the plasma of distant quasars. This isn't mysticism, it's math. Quantum field theory describes the vacuum as a seething foam of virtual particles constantly entangling and disentangling, a ceaseless dance of resonant energy. Practical applications are already emerging. Quantum computers leverage entangled qubits to perform calculations exponentially faster than classical bits, their power stemming from this vibrational synchronicity. Cryptographers dream of unhackable quantum networks where information is encoded in entangled photons, secure because any eavesdropping would disrupt their fragile harmony. Even biology hints at entanglement's reach. Some studies suggest photosynthesis in plants relies on quantum coherence, with energy vibrating through molecular structures near instantly, as if leaves have mastered the art of subatomic resonance. Yet the profoundest lesson lies beyond technology. If entanglement binds the universe through vibration, then separation itself might be an illusion. The same resonance linking particles could connect all things not as poetic metaphor but as physical fact. Ancient philosophy spoke of the web of life or the music of the spheres. Modern physics now whispers they were closer to truth than they knew. Every collision of particles, every flicker of thought, might be a note in a cosmic composition where no player ever truly acts alone. The universe doesn't just contain music, it performs it endlessly in a key we're only beginning to hear. From the thrum of a single atom to the slow, gravitational waves rippling between supermassive black holes, vibration isn't just something the universe does, it's what the universe is. Picture a spider's web glistening with morning dew, where plucking one silken thread sends tremors racing across the entire structure. Now imagine that web stretching across 14 billion light-years, its filaments vibrating at every conceivable frequency, from the high-pitched buzz of quantum foam to the subsonic groan of expanding spacetime. This isn't metaphor, it's the emerging paradigm of harmonic cosmology, reality as a dynamic, resonant tapestry where scale is an illusion, and everything from thought to gravity emerges from the same vibrational substrate. Consider how eerily this mirrors ancient intuition. Hindu sages spoke of Nada Brahma, the universe as sound. Pythagoras insisted celestial bodies moved in musical ratios. Even indigenous creation stories describe the world sung into existence. Today, quantum field theory lends startling credence to these visions. The standard model reduces particles to excited states of underlying fields, like notes plucked on invisible strings. Dark matter's gravitational pull might arise from unseen vibrations in higher dimensions. Even consciousness, that ineffable spark, could be a symphony of neural oscillations, a fleeting harmony in the brain's electromagnetic storm. The line between physics and philosophy blurs when you realize a quark's spin and a galaxy's rotation might just be different octaves of the same cosmic scale. Yet the true revelation lies in the connections. When LIGO detects gravitational waves from colliding neutron stars, it's not just observing an event, it's eavesdropping on spacetime's resonant language. Those ripples encode information about the star's masses, spins, and even the fabric of reality itself, just as a bell's ring reveals its shape and material. Zoom in, and you'll find the same principle in quantum entanglement, where particles remain mysteriously synchronized across light years, their states vibrating in lockstep as if space and time were mere suggestions. Whether at the Planck scale or across galactic superclusters, resonance is the universe's Rosetta Stone, translating between matter, energy, and the hidden codes of existence. What does this mean for our understanding of reality? If vibration is fundamental, then the distinctions we draw between things and forces might be arbitrary. A black hole's event horizon and the membrane of a human cell could both be resonant structures, differing only in frequency and complexity. The Big Bang's afterglow, the hum of dark matter, even the rhythmic firing of neurons, all might be verses in the same eternal song. Scientists now probe these harmonies with tools like quantum computers, whose qubits dance in coherent superposition, and gravitational wave telescopes, listening for spacetime's deepest bass notes. Perhaps the most humbling thought is this: when you strike a tuning fork or hum a melody, you're not just making noise, you're participating in the universe's oldest ritual, adding your vibration to a chorus that began with the first particles condensing from radiant energy. From the spin of electrons to the drift of galaxies, everything pulses, oscillates, resonates. We're not separate from the cosmos, we're its music, momentarily aware of itself. And as harmonic cosmology peels back layer after layer, we're not just uncovering how the universe works, we're learning how it sings. The phantom vibration of the universe isn't just background noise, it's the signature of reality itself, a rhythmic fingerprint left on everything from the spin of electrons to the slow dance of galaxies. Think of it like this: when you tap a wine glass and it sings with a pure, clear tone, you're hearing its natural resonant frequency, the pitch at which it vibrates most effortlessly. Now imagine that same principle scaled up to cosmic proportions. The universe isn't silent. It's a chorus of vibrations, each one a clue to the hidden architecture of existence. Take something as familiar as light. What we perceive as color is just our brain's interpretation of different electromagnetic frequencies, vibrations, rippling through the fabric of space at specific wavelengths. The red of a sunset hums at around 430 terahertz, while the blue of a midday sky pulses at 750 terahertz. Even the warmth of sunlight on your skin is the work of infrared vibrations, a reminder that what we call reality is really just a spectrum of resonant energy translated by our senses into something tangible. But here's where it gets profound. These vibrations aren't just passive features of the universe, they're active participants in its story. When two black holes spiral toward collision, their gravitational waves don't just carry energy, they encode information about the shape of space-time itself, like a phonograph record pressed with the grooves of cosmic history. The quantum jitter of particles in a lab, those fluctuations might hold the key to dark energy, the mysterious force accelerating the universe's expansion. Even the human brain, with its symphony of electrical oscillations, seems to tap into this vibrational fabric, suggesting that consciousness itself could be a kind of resonance, a fleeting harmony in the universe's endless song. What's truly humbling is how little of this symphony we've learned to hear. For centuries, we've relied on light to decipher the cosmos, but now, tools like LIGO and future quantum sensors are tuning us into new frequencies. Gravitational waves, neutrino oscillations, even the hypothetical hum of actions, each one is a new instrument in humanity's orchestra, letting us listen deeper than ever before. It's as if we've spent millennia admiring a painting, only to realize the canvas itself is vibrating, humming with layers of meaning we're just beginning to detect. So what does this mean for us? In a universe built on vibration, connection isn't just poetic, it's physical. The carbon in your bones, the iron in your blood, all forged in the resonant hearts of ancient stars, still carry the echoes of those stellar frequencies. When you feel a shiver listening to music or sense awe under a starry sky, you're not just reacting to beauty, you're responding to something deeper, a primal recognition of the rhythms that birthed you. As we keep exploring, remember, the universe isn't a static stage. It's a dynamic, ever-evolving performance, and each discovery is another note in humanity's growing understanding of the score. Whether you're a scientist scrutinizing data or simply someone who gazes up at the night sky, you're part of this grand investigation, so stay curious. The next time you feel your phone buzz in your pocket or hear the wind hum through the trees, pause for a second. That's not just sound or sensation, it's the universe whispering its secrets, inviting you to listen a little closer. If these mysteries resonate with you, join us as we keep unraveling them. Hit subscribe, and let's keep exploring the wonders hidden in the vibrations all around us. After all, the cosmos isn't just something we observe, it's something we're woven into, note by note, and the music never stops.